Are you ready? Okay. The first thing we need to check is our Excel file first. Okay. Just open up your Excel file. So I opening mine. You can open yours. So in your Excel file, of course, your group member will actually done the ratio for each company. Okay. So these are the ratio. If you see, I highlight them here. Okay. And this is your calculation. This is how you calculate to get this ratio. See? This is how you calculate them. This item actually extracted from the annual reports in the financial statement sections. So once you have all this ratio, you need to make sure that your ratio actually from the internal and external factors. When I say internal factors, I actually mean by bank specific factor. Yeah. And the external factor is your macroeconomics, all right, which I will show you later from this. Okay, now once you have all this data, you basically compile them. You see, this is how you compile according to the years. See, if you see year 2012, and here there are how many companies here? About 7. So you have actually 7 of performance ratio, which is ROA. You see, we have performance, liquidity, credit, operation, and so on. So how many ratio you should include in your study is depends on what would be your objective of your study. Yeah, if the objective of your study is mainly on risk, which is from internal factor, then these are the ratio. You have to get all these ratio from the past studies. Yeah, you can get those past study from Google Scholar or whatever articles, yeah, published in the journal and so on. Why we need this ratio has to be from past study, so that it has been verified. Yeah, it has been tested in many different situations. You see, once you arrange, like yourself, you'll be having here is 2013. Yeah, for this case, because this was the last year student, it was 2012 until 2016. For you, 2017. All right. So individually, your group member will do like this. Okay. So you will compile them. You see, these are the company names. If you see, how many of them? We have 7 companies. All right. For this case. Now, once you have this ratio, you need to combine them. This is important because this is gonna be included in your SPSS. How you combine? You don't put the calculation here. You see, the calculation, this one is removed. Only ratio remain. Yeah, ROA, ROE, and so on. You see, only ROA, ROE, current ratio, quick, average collection period, debt to income, operation, and so on. Yeah? And then you include your macroeconomic factor here, you see. Like in this case, the GDP of 2012 was 5.5. So we put 5.5 for the entire 7 company in the year 2012. This is all 2012. And here is 2013, 14, and the rest of it. Similarly, go to other variable, which is unemployment, inflation, interest rate, exchange rate, and so on. So what are other indicators that you need to include? Depends on your past study. You can include any macroeconomics that you think relevant to your studies. It's not limited. Okay? Now, why it is less better or more better? Of course, more number of variable allow you to explain your dependent variable better. Remember, we talk about dependent variable. Your dependent variable in this study is credit risk. Yeah, because you are doing the credit risk management in banking. Okay, now Once you already combine your data, what you need to do is you have to open your SPSS. Alright, we'll be loading the program. So you need to have your SPSS pre-installed in your system, otherwise you cannot run the analysis. Can you run the analysis using Excel? You can. If you are good in Excel, you can use Excel to run regression. Excel also able to run regression, but it's not very, easy to do it because it's not dedicated for this kind of analysis. Now, once you are in the program, what you need to do is you need to go for File, okay, and then you go for Import. All right, sorry, Import. Where is Import? Okay, if you cannot find Import, then you go to Open. Okay, if no import, go to Open. All right, Open, click on Data. Yeah, now this thing will appear. Yeah, so you have to indicate your file types. Your file types here is Excel. All right, and then you need to locate where is your file is located. So here is the file that I was working on just now. Okay, to double check, then I go, okay, this is my file names. Yeah, and then Open. You have to indicate which sheet, because in your Excel there are many sheets here, you see. So my sheet is Combine, you see here. So I go for Combine, the last one. Okay. Alright, once you click OK, the data will be loaded into SPSS. Now it is loaded. Alright, so but there are some issue here because there are some minus sign here, you see. So minus sign is very problematic for SPSS to read. So number one, you need to remove your minus sign from all your data. Okay, so that you neutralize your data. When you calculate, of course, you will have minus signs, yeah. But the thing is, this only used for your graph. But for your SPSS, you must remove the minus sign. But for your graph, your minus sign has to remain. Otherwise, the data will not be true. Okay. So now, what I do, I have to manually remove it. You see, if you have any, remove it. Okay, I remove it. Removing it now. Too many of it. Okay, this is what we call it as data cleaning. Yeah, in research, we clean the data. Why we do this? Just to make sure that you want to avoid the possible outlier in your data. You don't want outlier. Outlier means some data which is not normal, so that we try to remove them in order to ensure your result gonna be free from bias. Yeah. So it gonna be tedious job, but if it's not too many of them, then should be alright. If it's too many, then it's gonna be hectic somehow. So once you remove this data, make sure you save it in a separate file with the new names, so you don't have to recalculate again when you want to plot the graph. Okay, just save it in the different name. So now I'm removing some of these. Do you have any negative sign in your data? Okay, then you have to remove that as well. Okay. Okay, now we are set to go. All the negative sign, I suppose, has been cleared. So what do I have to do? I have to save it in a different names. Yeah. So maybe I say clean it. Okay. So what you need to do now, you need to go back to your Excel, go to File again, open, Data, then you locate your file once again. Now I go for Clean, open, then I locate my sheet, combine. Okay. You see, now all the negative sign has been removed. Alright? So what you need to do next, you have to remove these two, what we call it, column. Yeah? These two column has to be removed. So you go to variable, because when you run the analysis, you don't want these names in your variable. Because this is string, string. String is considered as character. So when character, your SPSS cannot analyze character with number. So you remove all these character. And these are years which is not should not be included as well. So we remove from here. It's very easy. Just highlight and then you right click. Okay. Or one by one, you can do like this. Clear. Clear. Okay, now you are done. Okay. When you go back to your data variable, it will be only like this. Okay. So the company names and the year. Here. Are you okay now? Oh, the screen is too small. Oh, you cannot see at all from there. Never mind, I will show you from here. Can you see here? Yeah, you should have told me. Okay, now, let's start from the beginning again, yeah? Okay, then we go for file. Okay, file. Okay, then you go for open, data. And then you go for Excel, correct? And then you locate your file, the one that we just cleaned just now. We remove all the negative sign and then you open. And then you choose your sheet. Alright, my sheet is in combine. Okay. Alright, it was something like this. Alright, so I need to remove these two because they are not number, they are string. So what I do, I go to variable, okay, and then I choose here. I do right click and clear. Company, right click and clear. Okay, and then you go to variable again, so data view, and then it's already removed. You see that? Once it is already removed, what you need to do now, you need to go to analyze. Okay, now it's important process. Once you go to analyze, you go to regression. Okay, you go to regression and then you go to linear. Can you see that? Okay, and then you click. Okay, now you are here. So what is your dependent variable? In your study you will have credit risk, but here, because these data are not bank, so they are not credit risk issue. So I look at liquidity. Let's say quick ratio. Quick ratio is for liquidity indicator. So I want to see what influence liquidity. So I choose it as dependent variable, and then I choose performance as independent. There are two variables here. Sometimes you can choose both, but sometimes you have to choose one only. I will explain to you how. Okay, now let's put both of them. And then, because liquidity is, current ratio is liquidity, so I don't include it. I either choose one only of the liquidity because they are both dependent variable. And then the rest I choose all. You see? You just press shift and then you highlight. Yeah? If you want to do it at one shot. If you want to do one by one, just press one every time you press here. Every time you press here. But if you want to do one shot, then you just shift, arrow down, and then you click here. Okay? So the next step, you go to statistics. In the statistics, you want descriptive to be there. You also want to have collinearity diagnostic. You also want confidence interval, and you also want Durbin-Watson. So these are the items that you need to click. Then you click continue. Okay? Have you seen that? Okay, once again. You click statistics, and then you have descriptive, you have collinearity diagnostic, and then you have confidence intervals and Durbin-Watson. What are these actually? These are the tests that we perform. So it depends on what methodology that you use. You know, in our case, we're gonna use a multiple linear regression, or we also call it OLS, ordinary least square. One of the user-friendly regression analysis. Okay, one of the most friendly and very common use in regression. Okay, now we continue, and then you go to plot. Okay, in the plot you choose Z-racet in the y-axis, Z-pred in the x-axis, and then you also go for histograms and normal probability plots. Okay, you tick both of them. And then you continue. Okay, remember, Z-racet in the y-axis, Z-pred in the x-axis. Continue. Okay, that's it. You don't have to do any other things now. Now you have to choose what method that we want. Okay, this method is very important. When we say enter method, the system will actually run the analysis according to the data that you arrange. Now we put it here, right? We choose which one first, which one next. But if you want the system to choose for you which one is the most significant to dependent variable, remember, we want to see which of these independent variable influence your dependent. We want to see what cause liquidity among these variables, which one has highest impact. You see, this is the advantage of doing regression using SPSS. Usually, you just predict and guess. You just guess that, oh, A affect B, C affect B. But no, now your statistic tools will tell you which one is influence the dependent variable. And then you will manage the risk accurately without having to guess. Okay, so if you choose enter, the analysis will be run according to what you have arranged. But if you choose stepwise, then the system will choose the best among these variables that influence dependent variable. Automatically it will choose for you which one is the most influence. Okay, so which of these you should use is depend on your objective again, your research objective. But commonly we use enter method. Okay, the most common we use enter. Now when your method is set, just okay. See? Now let the system do the magic. Alright, now we have the results. So your N here means your number of observation. You know observation? Like your company, you have one company 5 years, correct? If you have 5 members, means you will have 25 observation. Clear? 1 year equal to 1 observation. Yeah, if you have 100 years, then you will have 100 observation. So, is it better to have more observation? Of course. More observation allow you to generalize your finding. If possible, you choose every single. But in a research, in statistics, we cannot do that. We use only sample. Like we want to know about Malaysian, we cannot ask every Malaysian. It's going to be impossible. So we ask only the sample that should represent Malaysia. Remember? Yeah. So how are we going to do that? That's something we call it sampling, which we're not going to cover in this class. You have to sit for research methodology for that. Yeah. So now, okay, now we already have the finding here. So from here, what actually tells you from this descriptive statistics? Basically, the descriptive statistics has three elements here. The first one, we have average, mean, and then standard deviation, and number of observation. So mean the average of your quick ratio. You know, quick ratio is the ratio that represents liquidity, in which will tell you that the most liquid, in the sense. Right? That's why we use quick ratio, because we use cash over current liabilities. That is the formula. Why we use cash? Because that is the most liquid. So in this case, what it say? It say that every $1 of liability you cover with $1.34 of asset. Understand or not? It means every $1 of debt, you know, you have debt, right? You reserve, or you have the cash to cover or with 1.34 cent. You know, $1.34 for every $1 liability. Get the idea now? So every $1 liability, you have $1.34 of asset. Okay, so that means you have a strong liquidity. Yeah. So the larger you have to reserve against your liability, means you have more ability to absorb insolvency. Yeah, you're more liquid. Second one, ROA. ROA means return on asset. The formula is income divided by total asset. You want to see how much is the profit you generate from asset. So in this case, it tells you what? It tells you every dollar of asset you generate 5 cents. Understand? Or in other words, you can also say 5%. Yeah? You can say that on average, or 5 cents, not 5%, because we are talking about dollar here. So on average, your profit is about 5 cents per every dollar you invest in asset. Understand or not? Every $1 you invest, you get 5 cents. Clear? Alright, and the rest you will explain like the way I explained just now. Okay, let's look at macro. GDP, they say that 5%, because GDP in percentage, remember? So your explanation has to be depends on your denomination. If your denomination is currency, you have to explain in currency. This one in percentage, you explain in percentage. GDP is on average 5%. Yeah, we are talking about how many years? We are talking about 2012 to 2016. Yeah, so that's what you're going to explain in your finding. So what standard deviation tells you? So standard deviation basically tells you that the dispersion. You know dispersion? You never study statistics? So how volatile are you? Okay, put it that way. How volatile? Volatile means how unpredictable are you? That's what we use standard deviation for. So standard deviation here is about 0.9. It's quite volatile, you see? So in this case, we volatile in terms of what? It also tells you that your liquidity is not stable. Sometimes $1, sometimes 2, sometimes 50 cents, sometimes, you know. So if you have zero standard deviation, mean you have fixed number here. It never change. The higher number of your standard deviation, the more different is your number of your average. Okay, so the higher standard deviation, the more unpredictable is your company. Now let's look at the correlation. So correlation, you will explain how the independent is moving with your dependent variable. You're getting the idea? It means how your independent actually react to your dependent variable. So let's look at the first one. You see, ROA is negatively correlated, meaning when it say negatively correlated, when ROA decrease, the liquidity increase. That's why we call it negative correlation. It will go like this. Yeah? Negative correlation. Meaning, if you want your profit to increase, what you need to do? You need to increase your liquidity, then your profit increase. You see, in this case, your liquidity increase, your profit decrease. You see that? When your liquidity decrease, then your profit increase. It go, negative correlation, and apply to the rest. All right? And now you want to see how significant are they. Significant means how they are truly correlated. You have to look at this number. You see, this number, the rule is it has to be less than 0.10. You see? This number. Can you see it? Yeah. This number has to be less than 0.10. So we see already from here, the first number is not significant. You see? It's not significantly correlated. Yeah, it's not. Yes, only operation margin is significant because it has less than 0.10 or 0.05, and the most significant is 0.001. If less than that, very, very, very significant. Okay, but in our case, we only have operation margin, which is p-value less than 0.5. Okay, we call it p-value, but this p-value for correlation. Yeah. Okay, the rest, this one is significant at lowest significant. We have 3 levels. 1 star, 2 star, and 3 stars. 1 star means less than 0.10. 1 star. 2 star, 0.05. 3 star, 0.001. Yeah, 3 star is the best. Mean the most significantly correlated. If you have 3 stars. Okay, now this is observation. No, nothing. Yeah, it will only tell you that how many of observation you include. More better. Okay, remember, more better. But in your case, you only have 25. Actually, not good enough. I should have asked you for 100, but you will die. Yeah. Suppose we are going to do the analysis. To have a good result, you need to have a good sample. But I only tell you so that you can actually understand the process. Accuracy, you will do it later. Yeah, when you finish, graduate, then you need accuracy. Okay. Now, your method, they already tell you, is an enter method. And here is important one also. We call it model summary. In model summary, what you need to see? You need to look at your R square. You see, we have 3 kind of R square here. What R square tells you is that how many of this variable or how much it explain your dependent variable. Explain means what? It can predict, it can explain your liquidity. In my case, I'm studying about liquidity. So, how much it can explain? Only 0.15, means only 15%. Not good enough. Okay, 15%. But it's also depend on your area of study. So, if you want to know your R square is good or not, you compare with past study. What they get. If similar study, maybe they get 3, so your is half of that. I mean, maybe you suggest future researcher to include other things. So meaning what? How to increase this number, you have to change your IV. independent variable. Yeah, change it, increase, or maybe you increase observation. Yeah, there are two ways. One, you increase observation. The other way, you increase the independent variable. Okay, so your Durbin-Watson rules, it should not be more than 3. It should not be more than 3. It should not be less than 1. That is the Durbin-Watson rule. Okay. Okay, so I'm not going to emphasize much here. When you study master degree, you will learn all this, yeah, automatically. All right, and then here is the F value, how much impact. Okay, this one also, the bigger is better. So your model basically not significant. See that? Because this one is very important here. If possible, it has to be less than 0.10. Yeah, minimum it has to be less than 0.10, or you can say 0.09. Okay, 0.09 is okay, or P is equal to 0.10 is still okay, but more than that, not significant. Okay, so in my case, not significant. So can I report this study? Still can, but not very strong. Okay. Oh, this is very important now. This is one of the most important. Okay, before I jump to that, you see why this thing become insignificant, and you can already see that it's because of few of these variable only significant, only 2. You see, only 1 and 2 out of many. Yeah, so that explain. Mean you include the wrong independent variable, or your independent variable is not, related to liquidity, maybe to other things. Yeah, liquidity not suitable. Yeah. So now, okay, this coefficient is one of the main explanation in your study. Now, when you want to tell your boss, when your boss asks you, okay, so what? Tell me, how should I manage my liquidity? Your boss will ask you that question. Then you will have to tell him that which one is the most important, and the boss will ask you, you tell me which one is the most important for liquidity. So to do that, you look at the T value. You see? The one that with the biggest T value is the most significant. Minus plus sign, not important. Maybe minus but large. Plus but large is significant. So in our case, T for operating margin is very high. You see that? Okay? So if you observe, when your T is very big, automatically it's significant. You see? This is significant mean it's related, it's influence. Now we are talking about the table that tells you which item influence your DV. This is the table that tells you which one influence. This table tells you which one related. Yeah, correlation, it tells you which one related to the DV. Coefficient tell you which one influence DV. Now we can know, okay, what to do to manage liquidity. So to manage liquidity, you need to deal with operating margin. Yeah, if you deal with operating margin, then your liquidity might improve. Okay, so how to know whether it's influence positive or negative? You look at the beta. You see, coefficient beta here. See, this is coefficient beta. Then you have to look at the sign. So in here it has negative sign, mean it's negatively influence the liquidity. Meaning what? When it decrease, your liquidity increase. Does it make sense to you? You know, operating margin, we look at the formula of operating margin here. You see, where is your operating margin? Okay, this is the operating margin. Okay, let's look at how they calculate it. So operating margin, basically earning before tax divided by your revenues. This is the formula. So meaning what? when these earnings decrease, see that? When these earnings decrease, your liquidity increase. Yeah, does it make any sense? It doesn't make sense, right? You see, it tells you that when your operating margin decrease, your liquidity start to increase. So what you need to do? Liquidity means your cash, right? Your cash. Your cash start to increase when your earning decrease. Yeah, perhaps we are talking about tax here. You know, when you deduct, earning before tax, we are considering other expenses. Remember expenses? We have revenue minus expenses, then we have earning before tax, before interest and tax. So for that reason, you need to manage your expenses. When you manage your expenses, your liquidity will improve. Okay? Other variable here, which one? And then we have ROA is significant too. ROA is significant, but it's positive. Yeah, it's positive. Meaning, if your profit increase, your liquidity increase. Yeah, that makes sense. Because when your profit increase, you have more cash. So when we have more cash, then definitely you have more reserve. Okay? So in this case, if you want to improve your liquidity, improve profit. Is it clear? So how about the rest of the items? So we look at this. VIF here, it should not be more than 10. When it is more than 10, it tells you that some variable here explaining the same thing. You need to drop one. You need to remove one. So that you reduce to be below 10. Okay? Now we look at, is it normal? You see, this is your distribution table. Okay? Bell curve. It has to be within the range. It's not that very good, but it is okay, acceptable. You see, anything that skewed means it's skewed to the left, it's skewed to the right, means it's not good. Your data having some issue. All right, and then this is the table that show you your data is normal or not. This round, has to be this dot has to be fall on this diagonal line. We call it, this is diagonal line. The best when you all these data point is fall on this line, mean it is perfectly fitted. Okay, and that usually does not happen. Something that near to this line is good enough already, but it is very far from this line, means some problem with your data. Yeah, you're wrong already. Okay, this is homogeneity. Yeah, I'm not going to talk much about that. All right, so from here, yeah, I think that will be all. Okay, for the regression here. Okay, the enter method. Okay, I will show you the other methods. Let's say just now we only have two variables that's significant, right? Okay, now we want to see, is there any other variable if I use different methods? Okay, then you go for regression again, you go to linear again. You just change this. You go for stepwise. See that? Everything leave it as it is. And then, okay. The data is, I have to use this data, okay. I go to analyze, I go to regression. Okay, this is same data, you see? Nothing changed. And then you just change methods. Okay, alright. Yeah, the stepwise, they don't want to run the analysis. See? No variable were entered into the equation. Okay, so in this case, you need to go back to the regression and check. Okay, Try your enter method again. So that means your data actually prefer enter methods only. Yeah. If the enter method doesn't works with you, you can try the stepwise. So when usually happen when you do your individual assignment. Yeah, when you do individual assignment, your data is limited. Okay, let me show you now. Okay, let's look at one example here. I have one example of your individual assignment here. Okay, hold on. Okay, this is the data for individual assignment. Oh, in the same data we have it. Okay, I just import. You see, just let me show you. Okay, now this is individual assignment data. You see that? Because you do it individually first, right? And then you compile here. Correct? When you compile, you combine like this. You see? So basically, when you do it individually, you will have this data. Okay, I will look the one that will have no negative. Okay, here, this one has no negative stuff. Okay. Oh, still got negative. Anyone? This one has negative too. Got negative, right? Can you see? Yeah, you can see from up there. Okay, never mind. I have another data which is already clean. Yeah, I think this is the one. Yeah, this is the one. Okay, you see that? This is the one. You see? Something like this. When you do an individual assignment, you get something like this. Alright? And your GDP, you will arrange like this. You see? Yeah, you will arrange like this. Every year, you see? Because 1 year for you, not 5, 5, 5, right? Okay, now what you need to do, you go to your SPSS again. Data. And then you locate your file. Double check the company name. Copy of raw data. Okay. Okay, this is the one. Okay, now which sheet? Which sheet? Complete. Combine. Okay, combine sheet. Alright, we go to combine sheet. Alright, now you get something like this. Alright? And then you go to the same process, remove this. You don't want year, you don't want company because they are string, you want number only. You go back to the data. Can you see now? Yeah, okay. And then we go for analyze, the same thing, analyze, regression, linear. We take the, okay, this time we go for profit. We want to see what influence profit. Okay, fine. Then we take all this variable, put it here. And then we go to statistics, the same statistics, descriptive, collinearity, confident, Durbin. Plot is also the same. And then histogram, normal probability plots. That's it, you're done. You're set to go. Okay. Okay, now this is the data that you have. You see, your observation only 5. See that? Because you only take 5 years from one company, your individual assignment. Yeah. And then the same thing, you will have correlation table. You have the method that you entered. You see, but the problem now, your adjusted R square is not appear. You see that? Right? Okay, why is this happening? Because your observation is too small. So what is the solution then? Okay, hold on. You see, nothing appears. You see that? So what you need to do now, you need to go back to analyze, go for regression, go to linear, then you change the method into stepwise. Okay? And then you run the analysis again. Usually it will appear now. You see? Now it appears. See? All the number appear already. Get? Okay? Alright, now you can start to explain. But the only problem now with the stepwise is they only choose the one that has most influence. The one that has no influence drop. You know, like you have included many already, you see here? But only one is chosen. You see, only one variable, which is your operating margin only. So all of those variables, only one that influence your profit is operating margin. Okay? For your individual assignment, you need to do stepwise. Because if you run the enter method, it will not appear number sometimes. Sometimes it will, sometimes it will not. If it does not, then you need to use stepwise. Is it correct? So how to explain the stepwise? You can Google for it. You know, you Google people, you know how to do it now. Okay, you just write the word how to explain stepwise method in regression. It will tell you with sample. It's very easy. Education now is too easy. Or enter methods is available. Yeah. Or you can also refer to past studies. I give it to you in the journal, in the website. Ijubs.com, IJUBS.com. Yeah, you get it there. It's available there. So you get that, then you analyze. You see, but your bell curve will be a little bit funny. Yeah, why? Because only one variable. You see, because you only have operating margin. Okay, and you see, this is 5 years. You see, your observation only 5 years. That's why you have 5 dot. And only one that has the closest to the diagonal line. See that? So basically it tells you that you need to look at more observation to make sure your study can be generalized. You understand generalized? I mean, if you're finding, you got this finding, you cannot be so proud of yourself and tell everybody that, you know what, this industry, you know, I don't know what industry is this, let's see. What company? Logistic company. You cannot conclude that Malaysian logistic company is operating margin influence because your observation only 5. You get the idea? If you want to say that logistic company in Malaysia, you need to collect all sample of logistic companies. Then you can say with confidence that Malaysian logistic company profit depends on operating margin. So what can you use with this data? You only expert about this company. You understand? Not the industry. Okay? So about this company, you can tell your boss that our company, to increase profit, we need to look at operating margin. Okay? So what way that operating margin is basically influenced, then you can look at here. You see? Beta is positive. Meaning if your operating margin is positive, your profit will increase. It makes very big sense here because operating margin formula is earning before interest and tax divided by revenue. So meaning if your earning increase, your profit increase. See that? So how to increase your profit? Reduce your expenses. Remember, the formula of earning before interest and tax is your revenue minus expenses. Remember? So to increase that number, you need to remove expenses. Deal with expenses, increase profit. Clear? Alright, so that is how you're going to explain in your individual assignments. Alright? And yeah, so far this is the one. Then I will show you another one. Okay, because we have one variable here, we call it beta. You see here? Beta, right? Don't know what the heck is beta then. Never mind, we'll show you. Alright. Okay, so alright, let's see what it is. So any question until here? I think it's very clear. Yeah. Basically, I'm recording this video. I hope it works. If it works, then I can share the video to your group. Yeah, it's working. Alright. Okay, fine. That's good.